Hi my friends. Today we create an assembly centrifugal regulator made of these all parts. You can recognize the counterweight and the cross shaft, which were modeled by us in my two previous tutorials. The other two standard parts are the ball bearings and the bolts presented here. So what is new for you is this housing created by me for you, this bushing, a limiter, some axles and some nuts. These are not difficult to create, but I want to mention that all of them can be downloaded from my web page, which is presented in the last paragraph of the description of these tutorials. You must know that technical documentation I had to make this is composed from these poor drawings. I identified parts here and I changed the solution, creating that housing and replacing this ring with a new part. I want you to know that in my next tutorial I'll present you the dynamic simulation of how does it function. The parts are here. Look at them from many angles. As you can see, they seem to be many and difficult, but if we made this one and this one, and we can download all of them from my web page, I think it would be not so complicated. Let's go! We start from standard millimeters IM, and we place the first part, half housing, placed grounded at origin. As you can see, this is the problem with the new versions of Inventor, that the modeling part has some orientation of coordinates and the assembly another one. I select this point to be used, and for you to see, I apply right button, set current view as home, fit to view. So when I press home, we see this presentation. Good. The other parts can be placed in order, alphabetical order. 1, 2, 3, 4 axles, escape, space. Bushing is only one. Counterweight 1, 2, 3, 4. Cross shaft, only one. Half housing at the end, but let's place it now. We'll use at the end. This bolt is not taken from the content center, as you can see. It's taken from my directory, but how did I place it there? Let me show you this procedure. You can always open a part from the content center. The part in our case is a fastener, a bolt with the head flanged, and I selected this one, double click, which is metric 10 with a length of 80. Okay, this is what I opened from the content center. Now I save it in my workplace, which means in the directory where the other parts are. So save as, not back in the content center, which is this, but in our workspace here. We save it over the existing one. I placed there, and now I close it because I can place from my directory 1, 2 pieces like this. Let's make the same with the ball bearing. Open, now you know the procedure. Open from content center, the category is shaft parts, bearings, ball bearings, deep groove ball bearings, and then we go to SKF, the most important producer of bearings in the world. We consult, we know dimensions, 55 inside and 100 outside, and the thickness is 21, 55, the inside diameter is here, and 100 is here. This is our selection. Okay, and you see the ball bearing. Let's save it in our workspace. Okay, and now we place it from our directory. You can take them directly from the content center and place in your assembly, no problem. We know this, but here I want to have all of them in a unique group to be placed in my web page for you to download. Next, we place limiter. This is the limiter. Let me enlarge this screen. Then nuts. 1, 2, 3, 4, 5, 6, 7, 8. Then stud. 4 studs are necessary. I'll place them here. Okay, now these are all the parts we need. Now let's create the assembly. We start by placing ball bearings on the cross shaft. We use this option insert, and we place the first one on this place, apply, and the other one here on this face. You see, I select the face, this circle or this circle, but not this one. Yes, to have them face on face. Look, there, with its face on the face of the shaft. Okay. Now the same constraint, insert, for this external circle, but not this one, this one, to be placed in the housing here. Apply. Now we can rotate the cross shaft, but as you can see, the ball bearing doesn't rotate. We want to see them rotating. This is why I select these two, origin, to have access to their planes, origin, and I place the plane of the ball bearing, this or this, over the plane XY of the cross shaft. Yes, apply. And the same from the cross shaft, the XY, and from the other ball bearing, the plane, this plane. Okay, look now, I rotate the shaft and we see the ball bearing are also rotating. You have to know that these ball bearings are not an assembly. They are not two rings and many balls, but are a single part. Very nice. Let's place these nuts in these holes. Constraint, insert, flush. We select this circle, not this. Yes, to be placed, for instance, here. Apply. The next one is this one, and we place here. Apply. Now we rotate a little the shaft, and we constrain other nut, another hole, apply, also here. Okay, I rotate to have all of the 4 next holes in our view. One, 2, 3, 4. Okay, very nice. Now I place this limiter on the between this ball bearing and the shoulder of the cross shaft. Let me take this from here because it seems to be wrong. Okay, constraint, insert this circle to be placed over this. Apply. You see, they are without any Luft. In German is Luft. We don't see here a Luft. Good. Now let's place the counterweights using the same insert option. This must be placed here. Apply. Next one is to be placed here. Apply. Now I rotate the shaft to have all of them in our view. Constrain. The next and the last. Okay, as you can see, the counterweights are in position. Let's place the axles. Constrain, insert, flush. This is to be placed here. Apply. The next one is here. Apply. Now I rotate a little the shaft, the great shaft with the forks. Same flush for this to be placed here. I can select this circle, or the external one, but not this one. Apply. And the last to be placed here. Apply. Good. Next is the bushing. This is with some interesting problems. Constrain, axis on axis. Okay, no problem. Now it can be moved on vertical, even outside of the housing and everything, but what we want to be is to have this faces in contact with the cylindrical part of the counterweight, which was presented in my tutorial. To do this, we have to look inside. To look inside, I can make not visible this, or I can use a combination of keys, Alt V from visibility. In an assembly you can use Alt V, which is I select an object, Alt V, make it invisible, not visible, and then you see here that it is not visible, select it and Alt V. You have this option here, Alt V. Another one is Alt T to be transparent an object, not invisible. Let's see how is this. Alt T. You see the ball bearing is visible a little. I select it again, Alt T, and then select Alt V. We don't want to see now this. Now I want to rotate counterweight to be like this. Yes? Why? To apply tangent, the constraint tangent between this cylindrical face and this annular face, so that when I move the bushing, to see that they are moving together. To apply the same constraint to the other counterweights, I make this not visible. Now I see inside. I move this little to have a view at the other cylindrical face, constraint, tangent, this face, cylindrical on this face. Apply. Another is this one with this face. Okay. Now I rotate all as you can see to view this cylindrical face. There are many ways to do such a operation, but I use this one. Okay, now all of them are moving simultaneously. Look. Yes. Now I ask you, when does happen this? When the cross shaft will be rotating, yes? Because then the counterweight are pushed outwards by the centrifugal force, and the bushing will move up and down like this. Let's make again visible the cross shaft, visibility, Alt V, and we continue with our problems of assembling. But before, I want to show you what happens inside this mechanism. I select view, half section view, and I select this mid plane. Okay. If we look from here, we can see better inside. When I rotate the counterweight, the bushing is moving up. We can see that there is a very limited possibility of movement, because here is that cut, you know, from the cross shaft. This is to be moved only inside this cut. Good. But what are the limits of this movement? How can we stop the movement inside these limits? Look, this is the part I invented for you instead of that original one. You see, from this contact to this contact is all possibility of movement. Using Inventor, we can control these limits by notifying collisions, and we discussed about this in my previous tutorial. We go to Inspect, Analyze Interference, or Activate Contact Solver. These are the two possibilities. We can activate Contact Solver, but we have to select the parts which we supposed to be in collision. We make them contact set, yes, after selecting. And now, because this is activated, I cannot rotate the counterweight, but only in these limits, yes? Okay, we'll discuss about all this in the next tutorial when we apply dynamic simulation. Let's constrain the other components to finish this assembly. We go to Constrain, Insert, Flush, this to be here, but not at all, minus 6 millimeters, apply. You see? These studs must be placed to align the two halves of the housing and to fit them one to each other. I can apply from the start minus 6, and then I select one circle and another one. Apply. Minus 6 is for this and this hole. Apply. And the last is after. Apply, and after minus 6. Okay, F6. Now the other housing, face on face, apply, flush here, apply, and the planes. Yes, now I can move it only so, but I use perpendicular planes of half housing. One is here and the other is somewhere else. Look, it's here. I want to place them one after the other. To do this, I simply click and drag it near the other. Yes? Now I make them visible with their origin, and I select XY plane from one and the center point for the other when I apply constraint, of course. Okay, then the last are these two bolts. One is to be placed here, so I select this, apply, and the other is to be placed here. Okay, F6. That's all, my friends. Yes, next lesson will deal with the dynamic simulation, which will be very, very interesting. I am sure you will like it. That's all for today. Thanks for watching. Bye bye.